Hello, Accelerated Chemistry students. This is Mr. Spurk, and this is your Chapter 16, Section 1 notes, all over properties of solutions. So for solution formation, what factors affect how fast a substance dissolves? So granulated sugar dissolves faster than sugar cubes, and both granulated sugar and sugar cubes dissolve faster in hot tea or when you stir the tea. The composition of the solvent and the solute determine whether or not a substance will dissolve. They are agitation, temperature, particle size of the solute. Those are three factors that will affect how quickly the solute will dissolve in the solvent. So we'll first start with agitation. If the contents of the glass are stirred and the crystals will dissolve more quickly. The stirring is going to speed up the process because you're constantly bringing fresh solvent into contact with the solute. The dissolving process occurs at the surface of the sugar crystals. And agitation affects only the rate at which a solid solute dissolves, not the amount that will dissolve. So no matter how vigorously you stir, no more solute will dissolve. Temperature also has an effect on the rate. Sugar dissolves much more rapidly in hot tea than in iced tea. At a higher temperature, the kinetic energy of water molecules is greater than at lower temperature. So the water molecules are able to move faster, which increases the frequency of collisions between water molecules and the sugar crystals. The rate at which a solute dissolves also depends upon the size of the solute particles. The smaller particles in granulated sugar expose a much greater surface area to the colliding water particles. The more surface area of the solute that is exposed, the faster the rate of dissolving. So let's talk about solubility. A saturated solution contains the maximum amount of solute for a given quantity of solvent at a constant temperature and pressure. That is, no more solute can be dissolved into the solvent. In a saturated solution, a state of dynamic equilibrium exists between the solution and any undissolved solute, provided that the temperature remains constant. So as you can see by the little diagram on the right, the solvation occurs at the surface of the crystal, and those little crystal particles are being broken off from the surface. The solubility of a substance is the amount of solute that dissolves in a given quantity of a solvent at a specified temperature and pressure to produce a saturated solution. A solution that contains less solute than a saturated solution at any given temperature and pressure is an unsaturated solution. Some liquids, for example, water and ethanol, are infinitely soluble in each other. Two liquids are miscible if they dissolve in each other in all proportions. Liquids that are insoluble in each other are immiscible. Temperature affects the solubility of liquid, solid, and gaseous solutes in solvent. Both temperature and pressure affect the solubility of gaseous solutes. So temperature only affects solid, liquid, and gas, but temperature and pressure both affect gases. The solubility of most solid substances increases as the temperature of the solvent increases. However, there are a few substances where the solubility decreases with temperature, as you can see from this diagram on the right. We have temperature along the x-axis, and most of those lines are increasing the solubility as the temperature goes up, except for that bottom red line there is going to decrease as the temperature increases. A supersaturated solution contains more solute than it can theoretically hold at a given temperature. The effect of temperature on the solubility of gases in liquid solvents is the opposite that of solids. The solubilities of most gases are greater in cold water than in hot. This is where you want to think about like a pop. Your pop is made when it's cold, and that's how they get all of that carbon dioxide dissolved into solution. Changes in pressure have little effect on the solubility of solids and liquids, but pressure strongly influences the solubilities of gases. Gas solubility increases as the partial pressure of the gas above the solution increases. And a pop is bottled under high pressure of CO2 gas, which forces larger amounts of the gas into the solution. So since it's bottled under high pressure, that forces the gas into the liquid. When it's opened, the partial pressure of the CO2 above the liquid decreases rapidly. So bubbles of CO2 form in the liquid, which are then going to escape the bottle. That's why when you crack open your bottle, the pressure decreases, and all of a sudden you see all of this fizzing occurring. Henry's law states that at given temperature, the solubility, or S, of a gas in a liquid is directly proportional to the pressure of the gas above the liquid. As the pressure of the gas above the liquid increases, the solubility of the gas increases. As the pressure of the gas decreases, the solubility of the gas decreases. And we can write that relationship as S1 over P1 equals S2 over P2. So let's do a quick practice problem using Henry's law. If the solubility of a gas in water is 0.77 grams per liter at 3.5 atm of pressure, what is its solubility at 1 atm of pressure? So we're going to hold the temperature constant in this case. So what we're going to do is just use S1 over P1 equals S2 over P2. So we have 0.77 grams per liter over 3.5 atm, and that's equal to S2, that's what we're solving for 1.0 atm. And when we rearrange this, we cross multiply, divide, and we solve for S2. We're going to get 0.22 grams per liter. So what that means is that at a lower pressure, when the pressure is decreased from 3.5 atm to 1 atm, only 0.22 grams per liter of this gas will dissolve. So as a quick review, factors that determine how fast a substance dissolves are stirring, temperature, and surface area. In a saturated solution, a state of dynamic equilibrium exists between the solution and any undissolved solute, provided that the temperature remains constant. And lastly, the temperature affects the solubility of solid, liquid, and gaseous solutes in a solvent, but both temperature and pressure affect the solubility of gaseous solutes. As always, all the information on these slides has been acquired and adapted from Pearson Chemistry, 2012 edition of the textbook, Resources CD, and PearsonChem.com. Have a great rest of your day.